All right, so this set of notes is going to be over the second half of the 2.1 notes that we talked about just a second ago, but we are going to be talking about reviewing how to factor. And depending on where you came from, how you factor will be different than how I teach it, or it might be the exact same. It just kind of depends on, where you came from. So I'm going to show you guys how to factor using the most common method, which is called factoring by grouping. And factoring by grouping works for any kind of trinomial or a polynomial that has three terms in it, which if you look at all of these problems, all of them except for number 7 and number 4 are technically trinomials. They all have three terms in them. So it doesn't matter. It doesn't matter what they look like. As long as they have three terms, we can do factoring by grouping, and as long as they have like an x squared, an x, and then a number without a variable with it. So if we look at 1, 2, 3, 5, 6, and 8, all of those are in the form that we need it to be in order to do factoring by grouping. And if you look at numbers like 1 through 3, notice that the x squared doesn't have a number in front of it, but like for question 5, 6, and 8, there is a number in front of x squared. The number doesn't, you're still going to do the same thing from 1, 2, 3 as you're going to do for 5, 6, and 8. It's just going to look a little bit different because there's a bigger number in front for the right half, and then it doesn't look like there's anything in front for the left half, but there really is. So what I'm going to do is I'm actually going to start with number 6. I'm going to kind of jump around, and I think number 6 is actually one of the easier ones to like visually look at for this to make sense, and then we'll go back and we'll do some of the other ones from the left hand side. Sorry. Okay. So when we do factoring by grouping, we want to check to see if we have a greatest common factor within our trinomial. And if we look, the first term and the second term both have an x in it, but the last term does not. So I know that there's not a greatest common factor of an x. And then I've got a 3, a 2, and a 1, and the greatest common factor is 1, so I don't need to take that out. Later on, when I do factoring by grouping, you might have to take out a greatest common factor of 1, but when we're starting off, if the only GCF we have is a greatest common factor, then we're not going to take it out. All right. So what I like to do first is to draw an X on this side of your paper, and we are going to put some things in each of those quadrants. So what I'm going to do to start is I'm going to take whatever number is in front of x squared, and I'm going to multiply it by the last number in my trinomial. So 3 times -1 is -3, and when I multiply those together, I'm going to put that on top. I put a little dot in that top quadrant to represent multiplication, okay? And then I take my middle term, which is a +2, and I'm going to put that in the bottom quadrant, okay? And notice that I put a plus sign in the little corner of that quadrant. What I'm looking for the other two blanks on the left and the right of that x are the two numbers that multiply together to give me -3 that are going to add to give me a +2. So there's a couple things that I can do to multiply to get -3. I've got -1 times 3, and I've got a +1 times -3. Those two sets of numbers are going to multiply together to get me a -3. And now out of those two sets of numbers, which one of those are going to be able to add to get me a +2? Well, that's going to be this one, okay? If I were to add these together, I would get a -2, but in my problem, it specifically asks for a positive. So I'm going to use the top two numbers. So this one is going to be a -1, and this one's going to be a +3. And what I'm going to do is I'm going to highlight those. And where I had this +2x, I'm going to split it to be a -1x and a +3x. So this really doesn't exist anymore, okay? So what I'm going to do now is I'm going to write down my new expression. And instead of having that +2x in the middle, I have where it is split, okay? From here, I'm going to focus on the first two numbers together and then the last two numbers together. And pardon me, what I'm looking for is the greatest common factor, and I'm just going to focus on those two pairs of numbers. So 3x squared minus 1x has a greatest common factor of x, and then 3x minus 1 has a greatest common factor of 1. When you take out a greatest common factor, you always put it on the outside of a set of parentheses. And then we're going to divide the numerator, or the 3x squared minus 1x, by the greatest common factor, which we put in the denominator, and we made kind of like a little fraction there. So 3x squared divided by x leaves me with 3x, and then negative 1x divided by x leaves me with negative 1, and that takes care of that first part. Then when I look at the second half, I took out a positive 1, so I'm going to write that down next, and I'm going to put a plus there. 3x divided by 1 leaves me with 3x, and then negative 1 divided by 1 leaves me with negative 1. Now, whenever you do problems like this, you should be left with two sets of parentheses, and those two sets of parentheses should match each other. And if they do, then you've done it right, and if they don't, then you've done something wrong. So once I'm there, I'm going to take both of those pairs of parentheses, and I'm going to make them just one. So now I'm only going to have one parenthesis with 3x minus 1 in it. And then we take the leftovers, which were the greatest common factors that we took out, and we're going to make a parenthesis with that information in it. And I have factored that trinomial. Now, that might have seemed like a lot of steps, and it kind of is, but the more you factor and you practice factoring, the better at factoring you will be, okay? So that's just one example. We went through it kind of fast, but the steps are always the same. So now that I know how to do that, I'm going to go up to the one above it, which is number 5. And I skipped this one because it's got slightly bigger numbers and it's a little bit more challenging than that one. But the good news is the steps are the same. So the first thing that I check for is a greatest common factor just with those 3 terms that I see there. 4 and 20 are divisible by 4, but 7 is not. And then my first 2 terms have an x in them, but the last one does not. So as I'm just looking through here, trying to find a greatest common factor, there's not one. So I'm going to go ahead and draw my x off to the side. And then I'm going to take the first term and multiply it by the last term. So that's going to be 7 times negative 20. That's going to get me negative 140. And then I put a dot at the bottom of that quadrant to represent multiplication. Then I'm going to look at the middle term, and that is what's going to go down at the bottom. And I want 2 things that add together to get me a negative 4. So those 2 blanks on the left and the right of that quadrant of that x that we drew are going to be 2 numbers that multiply together to get me a negative 140 that also add to get me a negative 4. So what you can do is you can figure out all the things that multiply together to give you 140, and there's a lot of numbers out there. Just for the quickness of these notes, our answer is going to be 10 and 14. Now, I need it to multiply to get me a negative 140, so that means that one of those numbers has to be negative, and then those 2 numbers have to add to get me a negative 4. So I either have a positive 10 times a negative 14, or I've got a negative 10 times a positive 14. I don't like that there's a plus sign there. There we go. So the 2 numbers that are going to get me a negative 4 would be this one. So this will be a positive 10, and this will be a negative 14. I highlight those because those are what I'm going to use to split apart this 4x. So I have a positive 10x and a negative 14x. Now, whenever I grade students' work like quizzes and tests, the place where I find students make the most issues are when they split here, they forget to put an x down. Remember that we're trying to make a negative 4x, not just a negative 4. So we need to include the x's whenever we split it. Sorry, I sound gross. So I'm going to rewrite this as 7x squared, and then instead of a negative 4x, I now have a positive 10x and a negative 14x, and then a minus 20. From here, what I'm going to do is I'm going to look at the first 2 numbers and then the last 2, and I'm pulling out a greatest common factor. So between 7 and 10, there's not a greatest common factor, but between x squared and x, there is a greatest common factor of x. Now, as a rule of thumb, if this particular sign here is a negative, that means that I need to take out a negative. I almost never want that first term to be negative, so I know for a fact I need to take it out. It doesn't really matter what that sign is, but if the one that I have highlighted in blue is negative, I should be taking out a negative GCF with the second pair of numbers here. Sorry, I literally sound disgusting. Okay, so I can take out a negative, but I also think that I can take out a 2. Okay, Remember that your greatest common factor goes on the outside a set of parentheses, and then we're just dividing. So 7x squared divided by x leaves me with 7x, and then 10x divided by x leaves me with 10. Over here, I took out a negative 2 as my greatest common factor. So when I divide, I'm left with a positive 7x and then a positive 10. And your goal is to have the same set of parentheses twice, which we have. So we're going to write that once. And then remember that we grab the leftovers and we make our second set of parentheses that way. And there you go. Okay. Now, I do want to look over here, and I'm going to look at, we're going to do number 2, okay? This looks a little bit funky because when you look at this, it doesn't look like there's a number in front of x squared, but there is. The number that's in front of x squared is a 1. So if it makes you feel more comfortable to put a 1 there whenever you do this type of factoring, you should do that. There's not a greatest common factor with those 3 terms, so I'm going to go ahead and make my x, and then I'm just going to do this like I normally would. 1 times a positive 30 leaves me with a positive 30. And remember, we're multiplying to find that. And then I need my 2 numbers to add together to get me a negative 13. So when you think about all the things that multiply together to give you 30, you have 1 and 30, which is not helpful. You have 2 and 15, which might be helpful. But you also have 3 and 10. You also have 5 and 6. Okay, now I want these to multiply together to get me a positive 30, and the only way that's going to happen is if either both of my numbers are positive or both of my numbers are negative. And since they need to add to get me a negative 13, then they actually both need to be negative, because there's no way for me to get a positive 30 if one is positive and one is negative. So sometimes we have students who try to grab this one because 15 and 2 does make 13. But we have to be really careful and pay attention to the signs that we have. Remember that if I'm putting these 2 numbers down, they have to multiply together to get me a positive number, but then add together to get me a negative number. So we have to be very conscious of our signs. So the only thing that's going to give me both a positive 30 when I multiply and a negative 13 when I add is if I have a negative 3 and a negative 10. I'm going to highlight those, and then I split my negative 13x into a negative 3x and a negative 10x. From here, I'm just going to rewrite my expression. And then I'm going to take out the greatest common factor between the first 2 numbers and the second 2 numbers. So this is going to be an x. And then if you look, remember that we have this negative here and we don't want that. So we're going to need to take out a negative something. It could just be a negative 1, but we need to take out a negative in order for that middle sign to be positive. GCF goes on the outside, and then we just divide. This will be a negative 10. That leaves me with a positive x and a negative 3. The 2 parentheses match, which is great. And then I take my leftovers, which are on the outside, which were my original GCFs. And I make a set of parentheses with that. Okay, so that's how we do factoring by grouping. The only one that's a little bit different are numbers like 4 and 7, where we only have 2 terms instead of 3 terms. So if you were to see something like number 4 and there are not 3 terms, remember that we're always supposed to be looking for a greatest common factor first. And if you look, I only have 2 terms here, and I can take an x out of both of them. So I'm left with x plus 9, and that's all the factoring I can do. I'm actually done here. There's nothing else I can do. And then this one, I still have 2 terms. I can take out an x, but I can also take out a 9. So I take out my 9x, and I'm left with x minus 2. And then again, this is all I can do. So sometimes when you factor, it's just taking out a greatest common factor. We're not doing anything else. The only one that is super duper different from all the rest is number 8. And even so, it's not extremely different. We're looking for a greatest common factor, and all of my terms actually have a greatest common factor of 6. So I'm left with 9x squared minus 53x minus 6. And then what I would do from here, once I've taken out that greatest common factor, I'm just going to kind of ignore the 6 in the front for a minute. And I'm just going to focus on factoring with what's inside the parentheses. Everything else is done exactly the same as normal factoring. There's just the 6 in the front that kind of just goes along for the ride. And at the very end, your final answer will be 6. And then there will be 2 sets of parentheses that we would get when we would just do our normal factor by grouping. So if you haven't factored in a while. Hopefully that video helps you out. My notes, remember, are completed for you, so you can go ahead and try number 1 and number 3. The number 3 that's in our notes should be a positive 45. So this one looked a little bit weird, but it should be fixed for you. But yeah, and then if you want more practice factoring, please use like the Khan Academy that I provided for you and the iExcel that I provided. That way you guys can get all of the factoring practice that you can, because factoring is not just something that we do in geometry. You're going to see it again in Algebra 2. So that's all I have for you. As always, if you have